All right. So far, we have seen two simple applications about causation. And in essence, this is about the idea of counterfactuals and intervention. We can have counterfactual thinking to analysis causes to find out the actual cause. We can measure different types of causal effects based on, interviewing different treatments. And we also have seen how causal diagram played an important role amidst this application. But notice that in the previous example, we always have an established causal diagram. But what if, in turn, in practice, we need to find out the causal diagram from the environment? And that is literally how we got a name from one of the popular tests called causal discovery. And causal discovery is interesting in discover the causal diagram from the data, just as the equation shown here. So this is what we're going to talking about in this episode. But speaking of data, we might tend to associate it with machine learning and pattern recognition. If you literally treat the diagram as sort of pattern, then you felt like calling some data-driven method to discover this pattern from the data, right? This makes sense, but we have to notice that the machine itself doesn't know what is called causation, and the intelligence of the machine largely depends on how they can understand the features of the data. And here the feature refers to the statistical distribution of the data. But it turns out that the distribution can sometimes be unstable. That is, for example, if you have experienced this, if you do the same experiment in different environments, and you collect data from different environments, then the distribution of this data might be slight difference. And this is quite important because some of the data-driven methods are just sensitive to the slight difference. So given a sense, we might tend to asking, is there have some general principle? The principle is environment is unchangeable. So to better understand this, let's take the Newton's laws of motion. We know the force is the cause of changing the state of motion, right? And here, if we say something is unchangeable, something is environment, I mean the laws of physics. That is, no matter how large or how small the force you put into the object, if you hold constant the mass, then you will respectively observe varying degrees of acceleration, right? So let's come back to our context. So we might thinking for is there any invariant mechanism if we source from the data generation process? So um, so likely wise, we're wondering, is this anything called the laws of causality, which is we are expecting something like if you put different cause into the system, we expect this cause would be independent of the mechanism of this system. And here, notice that the system I mentioned here can be just vaguely represented or described by the causal diagram. Okay, so if we accept this idea and this ideas of invariant mechanism, and we're trying to blend this idea into the causal diagram, then this is how we got this rough picture of what we call the structure causal model, or SCM. And okay, this is the motivation. We're going to discuss a bit about SCM in the next video.